number 6 and 7.1. Of course, everybody has different numbers, but these are the numbers I have. A drug is used to help prevent blood clots in certain patients. In clinical trials among 4,751. So that number 4,751 is what is called the sample size N. 4,751. In clinical trials among 4,751 patients treated for the drug, 191 developed the adverse reaction of nausea. Construct a 95%, gonna call it level C level, confidence level. Construct a 95% confidence interval for the proportion of adverse reactions. So here you have like 5 parts or 4 parts in this problem. The first part is to find the point estimate. Point estimate. Now the point estimate again is the sample. Based on the sample, I cannot ask every single patient, do you have a blood clot or not? So we're sampling 4,751. The formula for the point estimate is p hat, which is x over n. The portion is 191, that is your x, and then you divide it by n. And it's just plain simple arithmetic. You divide and round it to 3 decimal places. 191 divided by 4751 is 0.040. That is your p hat. That is your point estimate. 0.040. If you were to change this to percent, it would be 4%. So based on the sample, 4% developed nausea when they took the drug. Now the next step, part B, is to find the margin of error. The margin of error E is Z alpha halves times the square root of P hat Q hat divided by N. Now, this critical value is based on the confidence level. So let me go back to my table that I made. If the confidence level is 95%, the critical value Z alpha halves that we need to use is 1.96. It is based on a bell-shaped curve with 95% in the middle, hence our range, our 2 values, with 2.5% on the left-hand side and 2.5% on the right-hand side. Why is that? Because it all has to add up to 100. That's where that number comes from. If you do inf norm 0.025, you get a negative 1.96. But since they are so common, you have them given. So your confidence level, the corresponding critical value is 1.96. So let me write this down. C alpha halves is 1.96. Now we have P hat. P hat was 0.04. We have N. How do we find Q hat? Q hat is the complement of P hat. 1 minus 0.04. Q hat is the complement, just like in chapter 4, the complement probability. If it rains 40%, doesn't rain 60%. So 1 minus 0.04 is 0.96. Now we have everything to find the margin of error. 1.96 times the square root of 0.04 times 0.96 divided by 4,751. Now it becomes a calculator problem, and you type it in literally exactly the same way as you see it there. 1.96 times second x squared, that opens the square root, 0.04 times 0.96 divided by 4,551. And we get 3 decimal places, 0.0055, so 0.006. Margins of errors in proportions are usually small. You don't want large margin of errors. Okay, that would be your margin of error. So far, we had to write it down and do the arithmetic. Is everybody with me? I mean, it's going kind of fast, but you have some idea, I hope. The next step is to construct the confidence interval. And for that, we're just strictly going to use the calculator.
I'm already dying here.
Calculator. So you go to Stat. Darlene, do you have a calculator in front of you?
Yes.
Okay, do you see Stat?
Yes.
And then you move your cursor over to Tests. Or
Okay.
highlight Tests. You see Tests?
Yes.
Okay. Now this is a proportion. You have to go down all the way to A, where it says 1 prop ZINT.
Okay.
1 proportion ZINT. So in the corner, you have the app just like me, right? Yeah. In the corner, you see X. Do you see X?
Yes.
Enter. What was X? I forgot. 191 for X.
191.
Press enter. And then enter N, the sample size, with 4,751. So 4,751. Press enter. And then the C level is 0.95. Press enter. Now on the other side, you see lower and upper. Ellen, can you mute yourself, please? 0.035.
Right. Sorry, I was just making sure. Might be a distraction for making the noise.
0.046.
Right.
Darlene, do you see that?
Mine says P equals and the N equals.
P and the N.
Yep. When I hit enter that first time, it came out with the 0.03462, comma, and
Oh yeah, you see that one. You see that 0.035, comma 0.046. You see that?
yes.
Yes, that in your case, that is your confidence interval.
Oh, okay.
Whatever's in the parentheses, that is it.
All right.
Now, the way you have to enter that in the calculator is P, which is our population proportion. Again, that is unknown to us. P is somewhere between 0.035 and 0.046. We have to write it like that. That would be the confidence interval. And if there are some problems where they're just asking you to find the confidence interval, when that is the case, you just use your calculator. You don't have to do anything that I did earlier. You only do it by hand if they're asking you for the margin of error. And of course, if they're asking you for the sample size. And then you have to, yeah, there's more. There's more. You get 2 for 1995. You also have to give it a conclusion. You are the statistician. You're making all the money. So the conclusions are pretty much the same. It must say there's an A, B, C, or D, and one has a 95% confidence that the interval from the lower to the upper does contain, this is important, it must say that, does contain the true population proportion. We are 95% confident that the interval or that the interval from low to high or upper does contain the true population proportion. That is one problem. How do you like it?
That was a lot for one problem.
Yeah, that was because that was going through everything. If you go on to number 7, it's just finding the confidence interval, which is just using the calculator. That's all you have to do. The same with number 8. You just use the calculator, and that's it.
All right. I think I got an understanding of it. I guess I just need to practice with it and see how that works out.
Yes. The only time, and that's the last thing I'm going to do, is starting with number 11, you now have to find the sample size.
Right.
Where are my 2 formulas? Right here. Sample size, formulas. Now let me read this problem to you real quick. In the study of government financial aid for college students, it becomes necessary to estimate the percentage of full-time college students who earn a bachelor's degree in 4 years. Find the sample size. Here you go. It tells you exactly. Now we need to find the sample size needed to estimate the percentage. Use a 0.04 margin of error. So E, the margin of error is 0.04. That's given. That's always given. And use a confidence level of 95%. So for A, it says, assume nothing is known. So when nothing is known, we have to use the first formula right here. First one in red. Nothing is known. We have E is given. E is 0.04, and that needs to be squared. The 0.25 is in my formula. How do I get this critical value for 95%? If you scroll up, here it is again. 95%, the corresponding critical value is 1.96. Guys, does that make sense? And that goes into this spot here.
Right.
1.96 squared.
Well, that's making a little more sense.
And now all you have to do is do the arithmetic. Use your calculator. and type it in exactly as you see it. 0.25, don't do anything fancy, times 1.96 squared. Divide that by 0.04 squared. And tell me what you get.
I don't know if this is right, but it says 600.25.
What did you get?
600.25.
600.25. Darlene, did you get that?
Not yet.
Yeah, do not put in the whole problem in, because I remember really badly that it will do the whole thing, but it doesn't do it by order. So
No, it does. It does. Put it in exactly as you see it.
I just
Trust
did the top part, then do the bottom part. Sorry.
No, that's all right.
It wasn't, I don't know if it was from this class, but I think it was from the pre-calculus. They don't accept the whole thing without
It's
the
probably
two
pre-calc,
quotation,
yeah.
without the two quotation bars, because it's thinking you're multiplying that first before you square root it or power to the second power.
Yeah, that's in pre-calc. But here we
Yeah.
can just type it in as you see it. That
I
way
got-
you.
I got
What?
600.25.
So you got 600.25.
Yeah, yes.
Okay. Now the computer says round up to the nearest integer. What would that be?
600.
It says round up to the nearest integer. And that is something you cannot forget.
Yeah.
We're talking about people. With people, you can never round down, because that would mean that maybe some extremities are gone. You always have to round up. It doesn't matter if it says 0.25 or 0.75.
So it would be 601.
601 is the correct answer.
All
That
right.
is the most common mistake in chapter 7.
No, because usually they just say round to the nearest integer. They're just usually just saying round it to, with
No,
a
but
decimal or something.
this one says round up. You must round up. It doesn't matter if what comes behind the decimal. After the decimal.
All right.
No more.
Even if it was 0.03.
Even if it was 600.0001, even if it was that, you still will round up to 601.
Okay.
Yep. Now let's do B and then we're done. Assume prior studies have shown that about 60% of full-time students earn bachelor's degree in 4-year degrees or less. So assume prior studies, about 60% of full-time students. So in this case, P hat is given. P hat is 60%. They give us that. So if P hat is 60%, what is Q hat then?
40.
40% or 0.4. But everything else is still the same. Z alpha halves is still 1.96 and E was 0.04. That has not changed. So now plug it in. 0.6 times 0.4, maybe I'll put them in parentheses, times 1.96 squared divided by 0.04 squared. I just put those decimals in parentheses so I know they are decimals. You don't have to. And with the calculator, I don't. I just type in 0.6 times 0.4 times 1.96 squared divided by 0.04 squared.
I get is 576.24.
I did too.
Okay, 576.24. Now, what do you enter in the calculator?
We have to round up to 577.
That is correct.
I mean, you don't need a calculator around it, but yeah. And that's it?
And that's it. It says round up.
All right, then. I'll see what I can do and see how it works. But like I said, I doubt I can finish all of it today. But as long as I understand, or at least practice it, I guess